Then other things besides math, naming acids. So you'll have some naming acids and probably bases, but remember, you already know how to name bases. It's just the metal and hydroxide. That's all that is. Then if I give you, like, say, a list of a bunch of different compounds, and I just ask you, is it soluble or insoluble? So as long as you know your solubility rules, that should be a give me. Then the main focus of this chapter are reactions, because that's where we really spent most of our time. So we had precipitation reactions. All right, so we did 3 types of reactions. We did precipitation and acid-base reactions. With both of those, you need to predict your products. So that's the same as saying writing the molecular equation. Write the complete ionic equation and the net ionic equation. Then with oxidation and reduction, you're just going to use your oxidation states to tell me who's being oxidized, who's being reduced, which one is your reducing agent, which one is your oxidizing agent. And then the last thing is using the activity series to determine if the reaction will occur spontaneously. The activity series will be given to you on your exam. So if you weren't here on Wednesday, make sure you pick up one. I'll give you this exact activity series. Where it is. So I would like to do several reaction examples. So we'll do precipitation and acid base first. I need to erase this part so that we have single room. Alright, so I'm going to give you a minute to try to see if you can get the right answer. Alright, so there's my products on the first one. Now I'm going to write the complete ionic. There's my complete ionic. Now I'm going to eliminate my spectator ions, which will be lithium and nitrate. So my net ionic then is just the formation of my precipitant. On number 2, and you get that far. Right, we'll do it real quick. I do have extra solubility tables also. Remember, I won't give you a solubility table on your exam. You have to know those. But if you weren't here when I passed them out, you can have another. So for this one, it's not a reaction. Why? Yes. They're both soluble, so there's no reaction. That was easy enough. Any questions about either of these? Or predicting products, spectator ions, anything? All right, let's look at 2 acid-base examples. There are 6 strong acids, and I cannot think of the 6th. Nitric. How did I forget? Okay, so these are your 6 strong acids. Everything else is a weak acid. I put an asterisk by sulfuric acid because that's actually a diprotic acid. So it ionizes in a stepwise manner. We don't really want to talk about that. And all strong bases have OH in the formula. I'm telling you this because if it's not strong, that changes your complete ionic and your net ionic. So this first one, both have a strong acid and a strong base. Strong acid, strong base. Because they are both strong, that means they will break apart in my complete and my net ionic. So my products It's going to be a salt, always a salt, and water. Always make sure that you do check your solubility rules on the salt that you form. Not all of them will be soluble. Alright, now I need to balance it. Now I can write my complete and my net ionic equation. That's my complete ionic equation. Now I'm going to eliminate my spectators. Bring down the rest. You can reduce this net ionic equation down if you want to, or I'll accept it like that, either way. So anytime you have a strong acid and a strong base, your net ionic equation should just be the formation of water. Okay, number 2, hydrocyanic acid is not on my strong acid list, so this is a weak acid. What does that mean for me? First off, means I need to use the other arrow. I need to use that arrow. When I go to form my products, I form my products just the same as with a strong acid. The only changes we're going to make is in our complete and our net ionic equation. So let's go ahead, predict our products. Lithium with anything is soluble. So I have lithium cyanide and water as my products, and it is balanced. Right, now, here's where things are different. Because HCN is a weak acid, you leave it together, you do not break it up. Okay, it's a weak electrolyte, so it doesn't dissociate completely in solution. We covered that at the very beginning of this chapter. This should say strong base. Okay, I do break up my strong base. My salt is soluble, so I break it up. Okay, so that is my complete ionic equation. Do I have any spectator ions? If so, who? Lithium. Lithium's my only spectator because it's the only one that remains the same on both sides. So I bring everything else down. So my net ionic equation looks very different from the one above because my weak acid is still there. Any questions about either of those? Yes,
So it's just like the base that dissociates and not the
acid. Okay, let's do oxidation and reduction. Wish these equations were a little bit longer. Alright, so for both of these equations, I want you to go through, assign oxidation states. From that, you're going to identify the element being oxidized, the element being reduced. Then tell me who's the oxidizing agent, who's the reducing agent. While y'all do that, I'm going to go ahead and start passing out the old exams. Alright, I'm going to go through real quick. Sign oxidation states. You'll notice that I did not do my sulfates individually because they stayed the same the whole way through. So I just didn't even worry about doing sulfur and oxygen individually. But I could have. It just needs to add up to -2. Alright, once I've gone through and I've assigned all my numbers, I need to look for changes. Alright, so all the sulfates, hydrogens, and oxygens stayed the same. And potassium. The only thing that changed is SN went from +2 to +4. So is it being oxidized or reduced? Okay. Then chromium went from +6 to +3, so it decreased, so it's being reduced. Okay. Then oxidizing agent and reducing agent. SnSO4 is the reducing agent. And this is what I covered on Wednesday. The reducing agent contains the element being oxidized. So SnSO4 is my reducing agent. So potassium dichromate is my oxidizing agent. Because the oxidizing agent contains the element being reduced. Alright, I'm going to do the same thing here. Alright, SB goes from +3 to +5, so it increases. So it's being oxidized. Meaning SB SO4 is my reducing agent. Then manganese goes from +7 to +2, so it's being reduced. Meaning KMnO4 is my oxidizing agent. Okay, so I have plenty of oxidation reduction practice up here for you. The only thing I haven't done an example of is with the activity series, but y'all shouldn't have problems with that. If so, you need to watch the last part of chapter 8's lecture. All right, we have 9 minutes to talk about your final. All right, so you need to use all of your old tests as kind of a study guide. Like if it was important enough for me to ask on a regular test, it's probably important enough for me to ask on the final. I'm not saying it's going to be just like your final. I mean, your old tests are just like your final. I had a piece of paper if I could, find it. Here it is. Alright, so my old final is pretty long, but I'm thinking about shortening it because I don't want y'all here for the whole 3 hours. So, normally I have 40 to 50 multiple choice questions, okay? And it's pretty evenly distributed between chapters 1 through 8. Okay, so I don't like just focus on chapter 8 or just focus on chapter 1 and 2. I try to evenly distribute it. Then I have 20 naming problems, just like on your old test. 10 where I give you a formula, you give me the name. 10, I give you the name, you give me the formula. That will include naming acids, which is what we just learned in chapter 8. Then the rest is short answer. And here are the short answer questions that I ask. The 7 elements that exist in nature as a diatomic molecule. So hydrogen, oxygen, all those. Electron configuration. And that is structured just like your old test. I'll say, write the electron configuration, draw the orbital diagram for the valence electrons, assign the 4 quantum numbers to the last electron you placed in the last orbital. Make sure that when you're studying electron configuration, you go back and you look at the exceptions that were in the D block and the electron configuration of ions. Then you'll have a few where you have to draw the Lewis structure. You'll have one where you have to draw 3 resonance structures. Look at the exam I just passed back today. I think it was number 2 or 3 that you had to do that on. Then 1 or 2 oxidation reduction like this. Then there are 4 where you have to predict products, write the molecular equation, the complete ionic, and the net ionic equation. So with those 4, 2 will be acid-base, 2 will be precipitation. Okay, so this means that all of the math is in the multiple choice. That's a good thing and a bad thing. It means there's no partial credit for your math problems. But it also means they're multiple choice, so you'll know if you're way off from the correct answer. Okay? So, Monday, we will take exam 4. I will have those graded by Tuesday or Wednesday. You can come pick them up so that you can use those to study. Then some of you are taking it Thursday, the rest of you are taking it on Friday. All right. See y'all Monday.